Hi friends, GPT-5 is released today and I'm sure you have been going through lots of demos, benchmarking results, etc. Let's build an AI agent for treasure hunting using GPT-5. In case if you haven't played the game before, all participants start at the same location and some clues are placed at different locations in the form of riddles, logics, puzzles, etc. The participants are supposed to use those clues to find out where the treasure is. Okay, we will mimic the same using the folder structure like here. For example, let's say this is the starting point and here we have some welcome message along with the rules. Now the participants have four options. Okay, so they can either choose to go with this folder alter or the other one, this one, this one, right? So think of these folders like four different directions or four different paths. Now let's look at the rules. It's simple. It says use your tools wisely and be aware of false paths and red herrings. Now sometimes these clues are placed to mislead the participants. Okay, all right, let's see the welcome message. Welcome, brave explorers. The crystal crown awaits those clever enough to solve the ancient puzzles. Right? As I said, the clues are in the form of riddles, logics, etc. So those are not straightforward to understand or figure out which paths to take. Right? Now, let's say we have a participant and given these four options, the participant choose this path. Okay? Now, again, after choosing this path, the participant has only one option. So let's say they choose this path and there is nothing. So the participant go back. So from shrine, go to altar and let's say they came to the starting point and then they choose a different path. Okay. Now here, again, we have three directions or three paths. Okay, let's choose this one. There is something. Let's look at the content and it says you are going in circles, turn back. Okay, that's again the end. That's not a right path. So the participant go back and let's look what's inside. Oh, that's the treasure, right? So here it says, congratulations, you found the ancient tomb. Don't worry, this is just some statistics about the puzzle, but the participant has found the treasure, right? So that's how we are simulating the real world treasure hunt using these folder paths and the clues. Now this is a super simple one. Within 2 steps, we are able to figure out where the treasure hunt is. And here we have a more difficult one. Now, similar to before, it's a different puzzle. We have some rules, we have some welcome message, again, some clues. The participant can take different paths going here. As you can see, the depth or the route is very long. So this is a much more complex puzzle with lots of directions, clues, etc., etc. Now, let's build an AI agent. We give all this information to the agent and then we'll ask it to figure out where the treasure hunt is. And we will monitor how many steps the agent took and how long the compute time, as well as how many times it has used different tools. Okay. All right. Sorry, this one. Okay. All right. So first we need to build this puzzle or the game, right? So for this, we are importing a module called this procedural maze generator. We will see the code of it towards the end. But basically, we are doing a bunch of imports from this module for constructing the puzzle, all right, or the maze. So here we are constructing 3 different mazes with 3 different levels of difficulty. So the easy, medium, and the hard. And we are giving a few different parameters like this depth, etc. We will see that in a second when we discuss this procedural maze. And we also have different themes. These themes are used for constructing the folder names or the paths, as well as the clues, the puzzles, etc. All right. So we use the inputs to create those 3 puzzles. So this is how they look like, right? So if you see here, so we have created one easy maze, hard maze, and medium maze. Okay, 3 mazes with 3 different levels of complexity. All right. So after creating, here we have a short summary of each puzzle. So the first one, it's a simple one, easy one. The depth is only 2. The theme is fantasy. And now, if you look at the stats, here we have 13 folders which contain these 7 clue files. Okay. All right, so we have the root folder. Within the root folder, we have 12 folders with different paths and etc. And here we also have the solution, but we will not be giving the solution to the agent. Agent is supposed to find this solution. Okay, then we have the medium one. As you can see, this time we have 20 nodes and some 10 clue files, etc. Now the treasure is at a depth of 3, as you can see from here. Here we have a complex one with longer route or a higher depth, right? Okay, 147 nodes and 48 files. All right, so we have constructed 3 different mazes, but for the purpose of this demo, let's work with only the easy maze. Okay, so again, constructing an easy maze, same configuration. So this time we have 9 nodes and 5 files. All right, so we are saving this in this maze 1. Now if we go to the folder, it's maze 1. So this is the one we are going to give it to the agent to solve. So all participants start here. Again, as we saw before, we have rules and welcome message. Then at the very beginning, there are only 2 routes or 2 directions, right? So the participant can take this route, and then if they take this route, they have 3 options, right? Whereas if they take this route, there also they have 3 routes, and there may be some clue as well. Okay, so here we have the welcome message, which says, welcome brave explorer, the crystal crown awaits those clever enough to solve the ancient puzzle. Okay, all right, so here we have a clue, ancient puzzle. So probably this is the right path to choose over the second path, which is called runes. Okay, so that's how we interpret the clues to figure out which might be the most likely correct path. Okay, that's how we solve the puzzles and do the treasure hunting. All right, okay, so we have constructed the puzzle. Now we are going to give the puzzle to agent to solve it, right? But we also need to give some tools to the agent so that it can navigate through the maze and it can understand the clues, right? So what does the agent need? One, the agent need to navigate through the folder structure, meaning it should be able to go to different folders and see what's the content of those folders. Okay, so we need one tool. And the second tool, it should be able to read the content of those files, those clue files, the welcome file, the rules files, etc. Right? So that's the second tool. All right. So again, two tools. One tool to navigate the folder structure. The second tool to read the content of the files. All right. So here we are defining the class called Agent Maze Toolkit, which has 2 functions. So here we have list directory. This is just checking, but here is the actual definition of the tool, which is simply given a folder path, it simply lists the content of that folder. Okay, and we are just doing some print, the folder, what are the subfolders within that folder, and if there are any files, what are those files. Okay, so the first tool is to simply figure out what's the content of the folder. Okay, and the second tool is read file, so to read the content of those files. Again, this is the tool, the main code. Here we are, once it has a file, we are giving the agent via this tool the ability to read those files. Okay, so the 2 tools are simply go through these folders, and if there are any files, read those files. Okay, those are the 2 tools. All right, now we have the system prompt. System prompt is just what we have been discussing. So you are competing in a procedural maze tournament. Okay, now this is a, we don't need to give this, so, but we are saying, okay, this is the difficulty, this is the team, the depth level, but this one is not really needed. This one is important. So we are saying, hey, this is where you start. The root folder structure is this maze path. Now your goal is to find the treasure. Okay, find the treasure hidden in this randomly generated maze. Now you have 2 tools available, list directory path. So that tool, you can use it to explore the directories. And the second tool is read file, which you can use to read the content of the files for clues. Okay, and then giving some additional instructions based on the theme of the puzzle or the maze. The folders are named and the clues are in accordance. So use all this information to figure out which is the best route to take, etc. All right, now here we have the task, which is actually the same because this agent is solving only those puzzles. All tasks are similar, so it's a bit redundant, but again, it's better to be explicit than implicit. Okay, so we define, we make it much more clearer to the agent what its job with this task prompt. Okay, all right, so here we are saying explore the maze structure systematically, read the files for clues and puzzle solution, decode any encrypted messages you find, because that's how the clues are constructed in the form of these riddles, puzzles, logics, etc. We can even have some math puzzles as well, and follow logical progression of clues to the treasure. All right, and we are also giving this warning: the maze contain both helpful clues as well as these red herrings or misleading clues. All right, so we have the system prompts as well. Now we are using llama index to construct our agent, which is this function agent, right? Because at the core of it, all we have is two tools in the form of these functions. So we want to construct a function calling agent which can call these two functions to figure out the task. All right, so these are the three models OpenAI has released today. GPT-5, that's the full version of the model. There is a mini version as well as nano version. Okay, all right, all we are doing is we are going over each LLM, and then we are accessing that LLM and using this agent maze toolkit class which we defined before. Here we instantiate the class which has two functions. Okay, now at the beginning of the puzzle, we are keep tracking of the number of tool calls the agent made, the time spent to solve the whole puzzle, and whether it is successful or not. Okay, so here we define the actual agent, the LLM, one of these three. We are going over all three of them one by one, and then here we have the tools, the two tools, list directory and read file, and then we have the system prompt. So here we have defined the system prompt using some template with some variables, right? The difficulty, the team depth, and maze path. So we are giving those 4 parameters here for constructing the system prompt, and similarly the task prompt. Okay, so we have everything. We are good to invoke the agent. So here we are invoking the agent with maximum iterations 100. Otherwise, these agent can keep doing infinite calls until it solves the puzzle, right? So we are setting maximum number of iterations it can take to 100. Now within each iteration, it can make as many calls, as many tool calls as it can, okay, as it want. Now all this is simply for tracking these 3 variables, okay? So, but if you don't understand anything in the code, let me know in the comments, I will explain. But all we want to do is we want to track these 3 parameters: tool calls, the total time spent, and it's successful or not. And we are tracking all those and simply printing that information here. All right, so we run through 3 LLMs. It's the same agent, but the brain is different. We have 3 versions of GPT-5, the full version, the mini version, and also the nano version. First, let me show you the final result. So here we have the full version. This one, it has made 45 tool calls. Remember, those tool calls are either display the content of the folder or read the file. Okay, so it has used 45 tool calls, and it took 195 seconds to solve this treasure hunt. The next version of the model, mini version, which is supposed to be less powerful, but this one took only 6 tool calls, and it solved the problem within 19 seconds. Okay, actually the mini did much better than the full version of the model, and then nano did somewhat similar to the full version of the model. Now we will see why this happened. Okay, so let's look at how the agent has solved this problem here in the output. So let's look at the mini version. Okay, so here we have the GPT-5 mini version. So at the very first step, when it is in the root folder, the only thing it can do is list the content of the directory, right? So for example, we are starting here, easy maze. So we are starting here. So the first thing agent will do is, hey, give me the content of this folder or list directory, right? So it should see these 4 things. So it called list directory, the path, maze 1, easy maze, that's the root. And now, as you can see, here we have 2 files, welcome as well as rules. And then it has 2 directories, these runes and ancient tomb chamber. Okay, remember when we call the list directory tool, that's what it's supposed to do, which is what we define here. So list directory tool, it display the content of the directory, and then here we are printing that folder, what subfolder / directories it has, as well as the files. Okay, so the agent made the first call to figure out what's in the root folder, which is good. And then since it saw these 2 files, now it has made 2 calls, 2 separate calls to read the content of those files. So read file. It has read the welcome file. It has read the rules file. Now the agent know this clue. So the clue is the crystal crown awaits those clever enough to solve ancient puzzles, right? If the agent understand what it means, then it will figure out which of these folders to take. whether it should be runes or ancient tomb chamber. Okay, let's see what it does. All right, after reading these two files, now the agent, it use the tool to see the content of the runes folder and then to see the content of the ancient tomb chamber. Okay, I thought it would use only this tool, the list tool, to read the content of this file, given we have this clue here, which suggests something related to this ancient, the crystal crown, things like that. So I thought it would use this ancient tomb, but that's okay. So here it saw the content of these two folders. So in the runes, there are three directories, right? Dungeon, crystal, and gem, whereas in the ancient tomb chamber, again, if we see here, so in the runes, there are these three folders. In the ancient tomb, there are three folders, as well as there is a file. Okay, all right. So next, from the ancient tomb chamber, it use the read file to read the golden idol.txt, the content of the file. Now, the content of the file says, hey, congratulations, you have found the crystal crown. Okay, so the agent has found the treasure. Now, remember, it's not based on the file name golden idol. It's supposed to read the content and then only it can figure out that's actually the treasure. Okay, which is what happened here. So as you can see, the moment it found this folder, it didn't stop there, right? It saw this file, but it didn't know that's the treasure, because we haven't instructed the agent that this actually is the treasure, right? So next, it used the read file to read the content of the file, and then it found out that this is the actual treasure. Okay, so this agent, all right, so the mini model has used 6 tool calls to find out the treasure, okay, which is what been summarized here. Okay, so it has used 6 tool calls. The total time spent 19 seconds. Now let's see what happened with this more powerful model, which has made 45 calls, and it also took way longer time, 185 seconds. Now let's come here. Okay, so this is the model. Now the first couple of steps are the same. So it starts with looking at the content of the starting or the root folder. So it found 2 files as well as 2 folders. Let me show. Yeah, so here we are. So we have 2 folders and 2 files. Okay, then it used read file to read the content of those 2 files, which is good. And then it looked into the runes folder and then the ancient tomb folder. Okay, so it looked into the 2 subfolders, runes folder and the ancient tomb folder, which is also fine. But then now if you see the runes folder, it contains 3 subfolders, dungeons, crystal, and gem. The ancient tomb folder, it contains 3 folders, or statue and altar. But next what happened is it tried to search for this ARP folder, which is actually in this ancient folder, but it is trying to search that within this ruins folder. Okay, I guess we can say it's some sort of hallucination, because it is looking for a folder which does not exist, or which exists in a different folder / path. Okay, so that's why it got into this error, no such file or directory, right? Because this ARP is within this ancient tomb chamber, not in runes. Now it keep repeated doing the same mistake over and over. So that's why you see this error number 2, no such file or directory, a number of times. Okay, so it made that mistake many number of times, and eventually again it looked into the ancient tomb chamber and it found, okay, there is a file with these 3 subfolders, and then it used the read file tool to read the content of this file, where it found, okay, this is the treasure. Okay, so that's where it stopped. But in order to do so, it has made 45 tool calls, and also since it is a more powerful / also larger model, it took 185 seconds. All right, somewhat similar thing happened with the nano model as well. Now this does not mean this model, mini model, is better than the original model. We need to run the same puzzle multiple times with different configurations, etc., and we need to take the average, the standard deviations, so and so forth, the statistics, to come to any reliable conclusion. All right, now let's see how we construct the maze actually. Okay, now going back to the folders, so let's see what do we need to have in order to construct this maze. Okay, one, we need to know, or we need to determine how depth we want to go, right? Or how long the route can be. Okay, so the depth of the folders, and then within each folder, how many subfolders we can have. Okay, and then maybe how often do we want to give the clues, right? Like these files, how often do we want to give the clues, and then how often do we want to give the clues which are misleading or red herring. Okay, that can be another parameter. And maybe the theme, right, which determine the folder names, as well as the clues, the puzzles, riddles, etc., etc. Okay, so we need to define all that information. Once we have that information, we do some sort of sampling in a systematic way to construct the maze. Okay, all right. So all this code is developed by Llama Index, and I give you the link to their Git repo. All right. So here we have the level of difficulty: easy, medium, hard, and expert. And then for the clues, we can have different type of clues: the coordinates, riddles, pattern, math, logic, etc. Okay. And then here are the parameters, right? The depth of the folders, and branching factor, meaning within a folder how many subfolders we want to have. The difficulty we looked at, the red herring ratio, how often we want to give misleading clues, the puzzle density, how many directories have puzzles, and then some name, theme, so on and so forth. Okay, so once we define all these, we systematically sample from these configurations using some random numbers to construct the puzzles. Okay, so here we have themes. For example, within the fantasy theme, we have, for example, let's say these are the different types of locations. We have objects, creatures, treasures, sci-fi, etc., etc. And then coming to these riddles slash clues also. So here we have defined some templates for the clues, right? So for example, hey, welcome, brave explorer. The treasure name awaits those who are clever enough to solve the ancient puzzles. And then here we have another one: use your tools wisely, be aware of false path. This was the rules text. Like that, we define these configurations. From these configurations, we sample to systematically construct the maze. Okay, all right. Once we constructed the maze, it's all we did is we have defined these two tools, one for navigating the folder structure and the second one for reading the content of the files. Then using Llama Index, we define a function calling agent. Where is it? Yeah, we define a function calling agent. We simply give those two tools. We have a system prompt explaining what the puzzle is about. We have a task where we give some additional details, and we invoke the agent. We monitor the tool calls, the time, etc., etc. Okay. I hope you find this interesting. Thank you very much.